aerospace and defense machining. It's not just about engine parts, not just about propulsion components or aerostructures. It's also the housings for sensitive electronics. Sometimes a molded plastic housing isn't enough, doesn't provide enough protection for sensitive electronic systems, so a precise machined aluminum housing is necessary instead. This is an underappreciated aerospace component, so let's appreciate it. I'm Pete Zelinski. I'm at Advance CNC Machining in Grove City, Ohio. They specialize in machining center work. 4-axis, 5-axis, and housings like this are one of the specialties. Components like these, electronics housings, they've produced in probably 100 or so part numbers for a dozen or so customers in aerospace, defense, drones, industrial electronics, even for boats. A part like this has to be rigid, lightweight, tight sealing, and also it has to conform to all of the particular electronic components within it and has to allow exactly enough geometry to contain all of these interconnected components. So the result is some very precise details that need to locate with extreme precision relative to one another. So a deceptively challenging part, particularly with some very tricky features. So let's take a look at some of those difficult to machine features that the Advanced CNC team has to think about. These heat sinks are an example. So to hog out the material between each of these fins requires long, slender cutting tools run in such a way where there's no vibration or chatter that could destroy or impair the fin as it's being machined. But at the same time, it can't be cut so slowly that the machining cycle isn't productive. So the team here puts a lot of thought into toolpath strategies for thin fins like these. Another feature is features that are simple to machine in normal circumstances, but really hard to reach on a housing component. Like this separate example. These holes inside this small pocket would be very straightforward to machine normally, but how to access them given their location within this part. What makes them challenging is this intruding feature right here, this edge. The Advanced CNC team thinks a lot about holding of parts, the orientation, whether to use 4-axis, whether to use 5-axis, often with an eye toward reaching difficult to reach features like these. In this case, because the holes are parallel to the very edge that blocks it, the only solution here is a long tool holder extension allowing this small drill to get access despite the long length of this shoulder that gets in the way. Then there are the assembly components that are simple that lead to challenging features. A gasket, for example. A gasket, probably the most basic and fundamental component of a sealed assembly. The groove that holds the gasket is a challenging feature to machine and can be among the most challenging features of a part like this. Because if you think about it, to machine this gasket groove, a small end mill has to be buried in full engagement within the material for the length of that groove. Edge wear has to be managed carefully because any change in the dimensions of the tool create a change in the dimensions of the groove. The tight seal that's necessary with that gasket might be lost. So the gasket groove, very difficult feature, even though the gasket is a very simple and straightforward component. Then there are the details of the part that are invisible because they're so accessible. Like there's a hole down in here that is at a right angle to this wall that sticks up. How is it even possible to reach down in here and machine this right angle hole? Well, in the case of this hole, the advanced team was able to explore Couldn't we just attack it at an angle from both sides, different angle? In other words, go in at an angle on this side, different angle on this side. The result is a V cross section for that hole, but its purpose is to allow a cable to string through. That purpose is still fulfilled even at the V cross section, so that was the efficient solution in this case. The other important consideration is just how to hold a part like this overall. The housing like this starts as a solid block of aluminum, and most of the material gets machined away. And oftentimes the walls or the floor are even thinner, potentially much thinner than this housing. So how do you clamp it so that it doesn't distort during machining, or it doesn't distort when it's unclamped? Oftentimes the answer is not mechanical clamping at all. The Advance CNC team puts a lot of thought into work holding strategy, and for the very most delicate electronics housing components, sometimes in place of mechanical clamping, the solution is adhesive work holding instead.